Alright, let's go over this problem. I asked you guys to solve x squared plus 3x minus 18 by factoring. So this is in standard form. Ax squared plus bx plus c. And the reason why I need that is so I can actually factor it. Class a times c is negative 18. Your b value is equal to, your b value is 3. I need two numbers that multiply to be negative 18 but add to be 3. 6 and negative 3. I saw a couple of students mess up on the next step, okay, of different problems. So I would just recommend keep doing the x and the box for factoring. Class, what do I write here? 6 and x, and this one. What goes here? The first term, and here the last term, which is negative 18. The greatest common factor for this row is x. And the greatest common factor of this column is x. Greatest common factor? And this direction. In factoring, our answer is x plus 6, x minus 3. Pay attention. We didn't finish. Because although I'm solving by factoring, this is the factored form. Let's write that. Factored form. You didn't solve. You don't have x equals, right? So now we're actually going to set that equal to 0. And now we're going to apply the 0 product rule. X plus 6 equals 0. X minus 3 equals 0. If I subtract 6, subtract 3, or sorry, add 3, x is equal to what? Negative 6, and x is equal to positive 3. Raise your hand if you got that as your answer. And the reason why I did that is not only to review factoring, but now we actually have the solutions. So when we do this problem and it looks a little bit more complicated, our answers are what? X equals negative 6 and 3. You can look at your steps from yesterday. To solve this same problem by completing the square, the first thing we need to do is what? Move the c value. So how do you move the c value? I want to do the opposite, add 18. X squared plus 3x equals 18. Class, what does the next step say? Factor out the a value. Now put your finger on the a value. It's a 1. But if I factor out a 1, they all have a factor of 1. So that step is completed. You really only need to do that step when a value is equal to 1 or higher, such as this problem from yesterday, where this is a 4, so we factored out that 4. Does that make sense? Okay, now we don't have to factor out the a value. What's next? We need to what? Complete the square. Partner B tell partner A the equation or formula we need for completing the square. Aaron? What's the formula to complete the square? B over 2 squared. So I take b value, divide it in half, and square it. Class, what's our b value? 3. Uh-oh. Fraction. Oh no. Class, how many 3 halves do you have? And that becomes what? 9/4. Raise your hand if you got that. So to complete the square in this problem, I'm going to have to add here 9/4. Now another student from another class asked this question. Mr. Ng, in yesterday's lesson we had 4 colored boxes, and over here you only have 1. Why is that the case? Yeah, just as you said, the a's are already factored here. In this problem, the a value is greater than 1, and that's why I have those 4 colors or 4 boxes. Okay? Well, we just completed the square. Now we need to do what? We need to factor. A times c is 9/4, and your b value is 3. Two numbers that multiply to be 9/4, but the same 2 numbers add to be 3. It's 3 halves. If you multiply those, that's 9/4. And if you add those, that's 3 plus 3 is 6, and 6/2 is 3. Now I'll show you a quick trick. I think I showed that to you yesterday. If I did not, see it again. Put it in yellow. These 2 numbers are exactly the same. And it's right there, always, right before you square it to get an answer. Let's write that out. So now I have x plus 3 halves, x plus 3 halves equals 18. Now we're going to make it a perfect trinomial square. How many of these do I have?
2.
And then we just solve by the square root method. What should I do next, class? We're going to take the square root. What's left? Equals. Plus or minus, someone said, 3 radical 2. Remember, square root of 18 is the square root of 9 times the square root of 2, and the square root of 9 is what, class? 3. Let's go ahead and now subtract 3 halves. I'm left with x equals negative 3 halves plus or minus 3 radical 2. What's going here? That should be next one. This doesn't look the same, does it? I'm going to put this over 1, see if this helps. I want my denominator to be 2, so I'm going to have to multiply that number by 2/2. I have x equals negative 3 halves plus or minus. This 2 only goes to the outside, so it gives me 6 radical 2/2. And then I get x equals negative 3 plus 6 radical 2/2. And x equals negative 3 minus 6 radical 2/2. Now I have an issue. We did the same problem, didn't we? We were asked to solve the same. The class of our answer is the same. All right. Alright, so if I want to add these 18 plus 9 over 4, I'm going to have this over 1, and I'm going to multiply by 4 over 4, which would give us 72. This is 72, right? Yes? No?
Yeah.
17 over 4 plus 9 over 4. And 72 plus 9 gives us what? So this should be 81 over 4. Use a darker pen. You have a pencil. The reason why I don't use pencils so you can actually see this a lot easier. So now I need to take the square root of 81 over 4, which would give us 9 over 2. Class, negative 3 plus 9? And 6 over 2 is 3. So here, when it says x equals 3 plus or minus 9 over 2, that's 3 plus 9, which is 12. 12 divided by 2 is 6. And 3 minus 9. Class, what is 3 minus 9? Oh, that is a negative. Let's try that again. Let's go on this end here.
Can you redo the whole problem?
X equals negative 3 halves plus or minus 9 over 2. Let me separate that for you guys, for some of you guys who are not used to the plus or minus. So that is negative 3 halves plus 9 over 2, and negative 3 halves minus 9 over 2. Class, negative 3 plus 9 is, and 6 over 2 is, this one is 3. Negative 3 minus 9, and negative 12 divided by 2 is negative 6, which is the other solution. Alright, what does that mean? You can solve the quadratic in multiple ways. So if I give you the option on the quiz, for example, if I just said the word solve, you can choose factoring or completing the square. Raise your hand if you would choose factoring. Raise your hand if you would choose completing the square. You could. If I'm very specific, if I say the word solve this by completing the square and you show me this, that's wrong, right? Because if I say by completing the square and I don't see completing the square and you have the right answer, I'm still giving you a 0. Okay? For softball, it's like, show me a fly ball, throw it to third base, and then you throw it in the stands. And we're like staring, you're like, whoa, you don't know what you're doing. Okay? So don't let that become you. Now, the great thing about this is that if I ask you to solve it by both methods, and you're confident with factoring, that at least gives you an answer to check. Does that make sense? But class, does factoring always work? No. And that'll be tomorrow's lesson when we learn about the quadratic formula.
I love math.